Good morning, everybody. Welcome to our technical workshop number 13. And today we have the pleasure to have the Colombian Geological Survey with us, with the talk titled Thermal History of Exhumation of the Garzón Massif and the Evolution of the Caguán-Putumayo Basins. And we have three great speakers today. But before talking about that specific case, we will have great news for all the students in the last years of the universities for engineering and geology, as well as the group of people that would like to continue starting the Master Science in Colombia. So we have already in place the financial support for thesis for the last year students and postgraduate students through MinCiencias, and that specific opportunity is open the first week of June. In a couple of weeks, you will be able to register yourself under the ANH MinCiencias Convenio 751, and for sure you are going to get there some interesting news about your financial support for progressing your last year thesis or your Master Science in Colombia. For more details, please contact Diana Rua in MinCiencias or here, Daniel Rodriguez in the ANH. That is the email address, daniel.rodriguez@anh.gov.co. Don't forget as well that the agency has that opportunity or data with no cost for research in frontier basins. So if you select any of those topics in frontier basins, you are going to get the data for free with the support of the ANH and the help of the Colombia Geological Survey. That under Acuerdo number 002. Please contact Pedro Rangel and the Colombia Geological Survey, or as well Daniel Rodriguez here in the agency to get more details. So those are the good news, and we are very glad to announce that. Daniel is going to repeat this announcement at the end of this talk. Okay, so don't forget in May, we have those four interesting talks. Today we are located here on May 13. Next week, we are going to have again the Colombia Geological Survey talking about the Playfair Way cases in the Caribbean, in Colombia. And we will close up on May 27 with specific cases, the opportunities on Repelon, that is in San Jacinto area. Also, we are going to talk about opportunities in the Putumayo area and in the Llanos Basin as well in the last week of May. I mean, don't forget that in our website, you have those areas identified for interest to be nominated by the agency. We have grouped all of them on gas and condensate in the north part of the country, light oil in the middle MAC, and in middle oil, gravity gas oil in the Llanos Basin, heavy oil also in the southern part of the Llanos Basin. So don't hesitate to address all that information in our website and get it. Well, don't forget that we're trying to promote one talk on gas or transition fuel, and those are the one program this for the following months. Next week we are going to talk about gas in the Caribbean, and we have a very interesting speaker that next week. We will have in June 13 the MinCiencias Research Group talking about the LPG in Colombia, propane, butane. So the habitat of that specific deposit in Colombia, and that is the very interesting talk on gas. On July 8th, we will have the ANH talking about the Jan gas potential in Cretaceous rocks along the Eastern Cordillera of Colombia. Very interesting talk. As you know, we have in the Cordillera 117 TCFs as prospective resources there. Today, we have the pleasure to have three great speakers. Alejandro Piraquive, in few words, I mean, he's a geologist graduated from the National University in 2007, where he also obtained his Master Science degree in structural modeling and fracture analysis of the Eastern Cordillera foothills in 2011. His PhD research was focused in geothermochronology and tectonics of the Santa Marta and Guajira Massif, finished in 2017. Since 2018, Alejandro joined the Colombian Geological Survey, where he has conducted a postdoctoral research in provenance analysis of the Paleomesozoic sedimentary rocks of the Perijá Range, and other projects including quantitative provenance analysis, the study of thermal histories in the Upper Magdalena Valley and the Middle Mac, and the development of methodological approaches for uranium, plum, and thorium, etc. Dating of multiple mineral matrices at the Colombian Geological Survey Geochemical Center. Currently, he is leading the research project of the DAN. DAN is the area in charge of the the nuclear aspects in the Colombian Geological Survey. And he is integrating all the data, the Caguán and Putumayo basins, using petrothermochronological surface and subsurface data. He has more than 12 years of experience in geological mapping, tectonics, geothermochronology, and provenance analysis. We have also a pleasure to have Santiago León. He's a geologist engineer and holds a master's science degree in geochemistry and geotectonics from the University of Sao Paulo, Brazil, and his PhD thesis on the Neogem tectonostratigraphic evolution of the Northern Colombian Forearc Basin. It has been recently approved, at the National University of Colombia. Currently, Santiago is a consulting geologist working at the Colombian Geological Survey, and his work is mostly focused on the integration and interpretation of geochronological and thermochronological data, which he used to reconstruct the thermal history and the paleogeography of the southernmost Colombian Andes and the adjacent foreland basins. And also we have Sebastian Jimenez Rodriguez. He is a geologist from the National University of Colombia. Well, he graduated in 2011. He also received a master's and PhD of geoscience at the University of Arizona in 2015 and 2020, respectively. In his dissertation, he integrated stable and radiogenetic isotope geochemistry, as well as a radiometric dating to reconstruct the paleoaltimetry and paleoenvironmental evolution of the central Andes of the northern Chile and the upper rift in northeast Africa. Currently, Sebastian is a research geologist at the Colombian Geological Survey, working on the project Petrothermochronological of the Caguán-Putumayo Basin, where he combines field observation and sedimentological work with different techniques, including the triple U and PV dating, stable isotope thermochronology, as well as geochemical and mineralogical data to reconstruct the evolution of the basin, and the genetic condition that could affect the process involved in hydrocarbon generation. Okay, so welcome the group of the Colombian Geological Survey, and please everybody enjoy this talk. Alejandro.
Thank you very much, Dr. Miguel. I'm going to share now my screen for all of you to see. So yes, okay, I think we are done. Okay, I'm gonna put this over here. Okay, thank you very much for having us here in this space. Today we are gonna talk about the Caguán-Putumayo Basin and the Garzón Massif, a couple history of exhumation and basin evolution in the northern Andes. So for starting, we have this with summary of topics we are going to talk today, which are focused first. The first part will be given by me, talking about the geological setting, surface geology, and subsurface data that we have incorporated in our research. Then my colleagues will explain you about some sedimentary provenance, inverse thermal modeling of the basin, and stable isotope geochemistry, burial temperatures, and thermal maturity of the organic matter, which is an important proxy for understanding the oil generation. Finally, we are going to make a summary of Mesozoic paleogeography and thermokinematic modeling in one structural section that we've been developing the last months. And finally, we conclude with this some observations that we obtained. So we are located in the Caguán Putumayo Basin that covers most of this area, and is located in the realm between the Andes here and the western part of the Guyana Shield. So it's the junction between this part of the shield and the Andes. And of course, this yields different geological properties of the crust, but also a typical Andean deformation front, in which we have exposure of the Garzón Massif, which is the most prominent Proterozoic massif in the northern Andes. So we have, first, before starting, we have a methodological approach that we've been applying to this study. Our approach is focusing integrate different scale data obtained from outcrops, seismic surveys, well logs, well cores, cuttings, and of course, our isotopic and geochemical analysis, which yield quantitative information that allows to reconstruct paths for temperature, pressure, time, deformation. So all of these variables are easily constrained if you combine the power of chronometry and thermal closure of different isotopic systems. The core of this research is focused, of course, in the presence of basement heights that are very common in this part of the cratonic area of the Colombian territory, which are key factors that play an important fundamental role in the oil system, because they offer an amount of possibilities that affect the oil system, as the generation, the formation of reservoirs or stratigraphic troughs, and the entrapment of oil. So the chronometric power of the techniques allows to know when these basement heights are configured and when the sediments derived from them were deposited and were truncated or affected by the structures. This is a central concept in this research. Well, we are going to talk about the regional tectonic setting just a little bit. This is taken from Jimenez Mejia, 2011 work. So we have the realm of the Caguán Putumayo Basin, which is bounded to the north by the Macarena Ranch, Proterozoic emergent massif, which is very unlikely to the regional trend of the Eastern Cordillera. It's like almost oblique to the trend of the Cordillera. We also got at the south the Araraquara Ranch, which comprises the easternmost boundary of the Caguán Putumayo basins, in which we have outcrops of Paleozoic rocks. Also in the western side, we got the deformation front of the Andes. And here we have a typical foreland basin, in which we have in the hanging wall, the Proterozoic massif of the Garzón exposed. And here all the derived deposits from the syntectonic evolution of this deformation front. So all of these elements comprise the Caguán and Putumayo basin, which make it a complex and interesting basin and a frontier basin for exploration. From old history, compilated here from Ramos and Cediel, we know that this part of the basin is compromised by the taphrogenic process during the early Paleozoic that configured the original shape of these cratonic basins. That preserve mostly Paleozoic sediments in the easternmost part, which are crop on for example, in the Araraquara range. This is also a phenomenon observed in the Llanos basin, where we have the Arauca impactogen, which also accommodated Paleozoic sediments like Ordovician until Permian sediment. Most of these Paleozoic sequences are barely understood. There is not so much information, but they play an important role as well in the evolution of the basin, and made up the configuration of the basin since the Neoproterozoic times. So the further evolution, the Phanerozoic evolution of this basin is related intimately to this primary configuration that is very old, in fact. So this is a topic we will later are taking on. Well, for a more recent tectonic environment, I'm speaking about the Andes or the Andean orogeny. We have some data that explain to us that the latest exhumation pools occurred around the Miocene times, around 15 million years ago. This is well constrained. So most of the obtained ages in the Garzón Massif in the literature show that the exhumation is quite recent, it's Miocene, and we have no testimony of elder events in this by this technique. But we will see there are other part of this history that is going to be unveiled. We also, in this evolution, have some hypotheses of hydrocarbon regeneration Most of them are likely to indicate the origination of hydrocarbon from the upper Magdalena Valley basin. And that the hydrocarbon was generated in these paleo kitchens and migrated towards the foreland. And then after Garzón Massif exhumation, this migration was interrupted. So this is like the work hypothesis that is currently under study by us. And we will show you the data that validate some parts or discuss this hypothesis. And of course, the presence of the kitchens and the generation migration paths, and also the fundamental role that the Garzón Massif play in all this evolution. For the part of the surface geology, we study several areas that are labeled here by numbers. And these areas are the basement high exposure that that surround the Caguán and Putumayo basins. So we have here the Garzón Massif, in which we have a transect, for example, in the Valsillas, San Vicente del Caguán transect. Here is the Capella field, one of the only producing fields in this area. We have also the southern part of the basin composed by the southern part of the Garzón Massif and all the outcropping rocks near Mocoa region, when we have a current production of hydrocarbon here. We also have some outcrops in the Macarena Ranch, in the Baupés High, which here is at the Guaviare location, at the San Jose del Guaviare location. And in the southern part, we have the Araraquara Ranch, which also exposed basement high, covered by Paleozoic sediments. All of these comprise the realm of the Caguán Putumayo basin. Locally, we were working in the southern part of the Garzón Massif. This is part of the project we've been developing with the Geological Survey at ANH the last year. So we have covered so far like more than 7,000 square kilometers of mapping. We have been documenting the structural relations and stratigraphic sequences that outcrop in all these eastern foothills, especially the Cretaceous sequences that, as I will show you, have some interesting characteristics that allow to relate them to the deposit of the Magdalena Valley. Everything is concealed by all of these crystalline massives that are exhumed and lost this, the sedimentary cover, and are defined also by several structures that control sleep and accommodate the strain inside the Eastern Cordillera foothills. For example, at the Sibundoy Valley, we have a tectonically shaped landscape, which is characterized by these verticalized thrust that give this part of the confined sediment rhomboedral pull-apart basins that are confined in intramontane setting. So this is product of a late tectonic episode during the Pliocene. Other example, for example, the very famous Algeciras fault, which is a major structure controlling the uplifting of the Eastern Cordillera at this portion of the Andes. We also have documented these kind of structures on the field, are a part of essential part of our structural reconstruction and modeling. Another aspect besides the structural are the stratigraphic relationship between the units. In most of the former maps, the relations of the units were mapped as tectonic contacts. But we observe a lot of unconformities between the Phanerozoic sediments and the Proterozoic sequences, Proterozoic basement, sorry, that it's outcropping in this part of the Eastern Cordillera. So we have at least 4 regional unconformities of Jurassic, Aptian, this is the base of the Caballos Formation, Maastrichtian, and Middle Eocene, the very regional Middle Eocene conformity of the Pepino Formation. This means that there were several episodes of basement uplift at this portion of the Andes before the Miocene exhumation. They are not documented in the thermochronological data, but the evidence of these uplifting episodes, it's unequivocal here. You can see, for example, these migmatites covered by sediments. And this has a very important implication of the paleogeography of the basin, because this information from the field directly shows us exposure to area exposure of the basement. This is very important because sometimes, for example, we got the Paleocene deposits of the Neme Formation, which have some oil seeps, overlaying unconformably these migmatitic gneisses of Las Margaritas unit. And we have in between the contact of the sediments, for example, you can see here a nice conglomerate. We have a weathering surface of the basement. This means that the basement was exposed to the surface, to the atmosphere, and the minerals decay into clay minerals, for example, feldspath and amphibole, start to decay into clay minerals. And this means that not only the basement was exhumed, but also was exposed to the weathering. And this has paleogeographical implications as well. And also it's showing us a stratigraphic exhumed trap. As you see, the oil seeps are continuous in this unit and it's truncated against the basement. So with this information, we made several stratigraphic sections and made the correlation. This is for the northern part, for the area of Belén, near Florencia, when we have a very diminished thickness of the Cretaceous sediments. Here, the Villeta and Caballos Formation have very low thicknesses that are increasing toward the southwest in this direction. For example, in Mocoa direction. For example, here we lack of fauna. Carbonate sequences are very scarce, but still you can identify the Cenomanian, Turonian sequences and the so-called Villeta Formation. When we go further south and we start doing these stratigraphic sections, we start to find that these deposits of the Cenomanian, Turonian, and early Coniacian part of the Cretaceous are thicker. The carbonate sequences are more abundant, and we start to find fauna. For example, this is location of the Rumillaco River section, which is here. It's one of the most representative that covers all the sediments of this part of the Mocoa Valley. And we, in these Cretaceous sequences, we also see correspondence with the ones that are found in the Sibundoy Valley, where also we have the sequences that are named by the nomenclature of the Upper Magdalena Valley. So we have the Tetuan, the Ondita, and Loma Gorda units, and also the Olini group. It can be recognized here. Of course, how we can make this correlation to work because of the fauna. So we found in both sides this fauna of ammonites, which is very common even in the Rumillaco River section and also in the Sibundoy Valley, and are characterized by Gnemiceras, Acanthoceratidae, ammonoids, and also other faunas, Sinoceramus, and other bivalves that are giving us the connection, the marine connection, since the late Aptian to the Coniacian between these basins. So this is very important because it means that the Upper Magdalena Valley Basin and the sediments that are found east of Mocoa share a marine corridor where all this fauna could move around. So the source rock that we found in the Upper Magdalena Valley is the same source rock that we are finding to the east of Mocoa, at least. And this rock has oil seeps, so it means that the rock generated oil, and also is the same, are the same sequences representing the same time spans and can be correlated. And this is paramount importance for stratigraphic correlations regionally, because now with this fauna evidence, we know these two basins are not independent anymore. They belong to the same marine system. Okay. Of course, a lot of fauna is still under classification, so we are working on it. Well, now I'm about to talk to you about the subsurface data. Okay. First, I'm going to start about the seismic interpretation. For this, I will recapitulate the first thing I told you about the paleogeographic configuration of basement heights inherited from a Proterozoic era. So we have now these basement heights, for example, the Baupés High and the Macarena High, and of course the Florencia High, and then we have the Garzón Massif over here. And all these heights are separated by depot centers. Some of them, we have no idea where is lying in this depot center because there is no well or seismic data, for example, in this Guaviare subbasin, and it's very restricted also in the Caquetá subbasin. We know, for example, that the Capella field is around here, and we have all our producing areas in this part of the Putumayo basin, westward of the Florencia High. Why we want to study these heights? Because, of course, they control the facial distribution of the source and reservoir rocks, and they control migration paths of oil, of course. And the exhumation histories are very different. For example, these heights are north-south oriented and are very different from the Andes. They are truncated against the Andes trend. So they have different story. We are trying to unveil this story. We have obtained like thermochemical exhumation ages, for example, Miocene for the Eastern Cordillera border for the Garzón Massif, around late Paleocene for the Macarena Ranch, and Cretaceous for the Baupés High. And this has several implications in sediment sourcing and distribution of the sedimentary phases of the Cretaceous, as my colleagues will explain later. This is the amount of information we've been collecting from these areas. So we have like some statistics of the volumes of 2D and 3D seismic and the wells that are incorporated in this investigation. As you can see in the northern part of the Caguán-Putumayo Basin, we have more restricted information. It's less developed, whereas in the southern part, we got a lot of coverage of at least seismic. So there are a lot of uncertainties there, even because we don't have a strong knowledge about, for example, these depositors and what might be in these depositors, okay? We first made several correlations in the northern part of the Putumayo Basin at the Garzón Massif, for example, for Capela, for the Guarango, Nogal, and Cachalote wells are our reference wells. And we start to observe a 4D characterized by the development of a passive roof syncline. When we have, for example, this typical foreland and with blind thrust, and we got the thinning of these horizons. For example, the Cretaceous pinch out against the Florencia High, which is one of the most important features now here in this part, controlling sedimentation, at least since the Cretaceous. Northward of the Florencia High, this means in the realm of the Capela area field, in the Caquetá subbasin, we have a different structural style characterized by verticalized thrust that involve like thick skin thrust that have this displacement, this typical tri-shear thick skin deformation. We don't have here like a syncline, a football syncline, but or a different style. So this means there is control, structural control from these different paleogeographical features over here. When we go northward and found the Capela oil field, we can see the geometry is also very different than for what is saw in the southern part. We here have this inverted semi-graben structure, half-graben, sorry, structure, which is producing now oil. And for part, for example, we an excerpt of this part of this section. This is the regional section from Valsillas to San Vicente del Caguán, when we have this verticalized thrust. And in the foreland, we got these also out of sequence thrusts that are breaking through the sediments. Some of them are not reaching the surface, but still are forming these compartments, which have also these lenticular geometries that may be indicative of inverted half-graben structures, which are a very important play in the area. And when we compare these towards the south, we go, for example, to the Ecuador domain in the ITT fields. We see similar plays. Well, could be analogous. We don't know if even, for example, the age of these sediments in the Capela field, for example, but we can infer at the first sight that we have some structures that look quite similar when we have these patterns of widening lenticular shapes covered by the lower Cretaceous unconformity. So one big question is, what is the age of these sediments really? Is this part of a Cretaceous sequence of probably older sequence? Still yet to be found. We are working on it. It's difficult because we only have the trital ages. So it's difficult to know where is the stratigraphic ages of this conglomerate because they do not yield any fauna so far documented. But it's a important play in the northern part of the Caguán-Putumayo area. For the second phase of this project that started this year, we're working towards the south, and we are looking these transects, which have several of different objectives that are, for example, identifying the depositors, defining the geometries, and studying, for example, the formation of structural and stratigraphic traps, which are also a major play in the area, given the existence of these basement heights. So when we see, for example, these regional transects, we see a similar pattern with this subandian and wedge top synclinal, and then the proximal 4D and an external 4D characterized by the Florencia High, in which all the Cretaceous sediments are pinching out. So this means the Cretaceous sedimentation was confined to the west of the Florencia High. So the question is, what is lying east of the Florencia High in these depositors? Is these pre-Cretaceous sediments? Are they in some point considered as part of an oil system? We don't know yet, but this is still to be acknowledged and studied. For example, in some of the soil transects, for example, this seismic transect, the number 1, which comes in this direction here, you can see under the Precretaceous unconformity, fossilized extensional structure, possibly from a Jurassic or probably older age, which we actually have no precise constraint for the age, but they are definitely Precretaceous. So which role they are playing in this evolution is still to be studied. This is very typical when we zoom in into these pinch outs. We can see, for example, how the Cretaceous sequences are just disappearing towards the height. You can see, for example, in these nice reflectors, the reflectors of the basement, like folded basement. And we have the very nice horizontal sequences of sediments followed by the, for example, Villeta, Rumillaco, Pepino, and Norte Guasa sequences like the Eocene, Oligocene. But you see the pinch out reaches this part, and this could be also interesting for a stratigraphic play. This is very typical as well towards the south, and you still can see the role, the important fundamental play by the Florencia High as a paleogeographic element controlling all Cretaceous sedimentation in the basin. And of course, because of the pinch out, we think this is a very important source of possible source of hydrocarbon to be studied and gives this basin a prospectivity that is still to be developed. Okay, because of the study, this stratigraphic termination could be an important asset to understand where the traps might be configured. So in this plain view, you can see, for example, the maps of the faults, and you can see, for example, how compartmentalized is the basin by the Florencia High that you are seeing here in the middle part. It's almost north-south oriented. And you can see how east of it, we have a basin composed by external folded, wedge top, and the Subandian domain. This will correspond to the Capella area domain. And in this part, to the west of the Florencia High, we have similar configuration of a Portland basin, but these two parts of the basin are dissected and have probably very different histories, tectonic, sedimentological, and exhumation histories that are to be acknowledged and studied in order to constrain if these bases were somehow connected. For example, it's fundamental to know when the Florencia High was uplifted, and if it was a pre-Cretaceous or late Cretaceous, or we suffered some reactivation. So these are questions we need to resolve using our geochronological isotopic tools. We also integrated well data. This is a map of distribution of the wells we have been using in this investigation. And we got, for example, this distribution of the phase 1 wells are these. And the phase 2, we're also involving wells from the upper Magdalena Valley, for example, the Iscana wells and Pantera also, which are very interesting because are cutting the Proterozoic basement, and in subtruss place, they have again sediments. So we got a tectonic override of the Proterozoic basement or Cenozoic deposits in this part at least, which is also observed in this part. So it's like a divergent origin. We also are sampling and studying the wells in this area because we want to have information about the source rock and the reservoirs here to compare isotopic and geochronological signatures and to see where are the sediments derived from, if they are derived from the shield or of the Andean domain. We have made some correlations using this well, and again, the Florencia High control sedimentation, so you can see how the Cretaceous sequences are pinching out towards the Florencia High, and thickness are diminishing. This happens, for example, in this part of the sun, in the southern sun, here. And this is very common also in this. Oh, sorry, Siri was interrupted. In this part of the area, we got again this correlation here, where we can see again how all the Cretaceous intervals of interest are diminishing their thicknesses towards the east and towards the north, as I showed you before. So again, the Florencia High is controlling all the sedimentation of this area. And if we made this correlation oriented like northeast, southwest, we also see from the structural point of view how this Florencia High controls sedimentation as well, and how the units are, for example, in the southern part, in this Pacayaco well or Rio Mocoa, we have greater thicknesses of the Albian to Cenomanian deposits, and northeastwards we start having less and less of these deposits. So this clearly shows a structural control of the Cretaceous sedimentation, and permits to say that the Florencia High was playing a role of a paleogeographic barrier, at least since the Albian. Well, I leave you here with my colleague Santiago. He will explain to you some feature about the sedimentary provenance that are related to this topic. Thank you very much, and Santiago, it's up to you. Thanks.
Okay, thanks, Alejandro, and thank you everyone for being here. Are you seeing my screen now?
Yes, it's visible.
Okay, so in this section, I will show you the main findings of our sedimentary provenance analysis. And as Alejandro told you, our sampling strategy involved a regional approach combined with the analysis of samples from stratigraphic sections and boreholes to study the sedimentary provenance of Cretaceous and Cenozoic strata. From the borehole samples collected from the Rio Pescado wells, we can see that the Cretaceous rocks, Cretaceous Paleocene rocks of the Neme Formation mostly include Mesoproterozoic detrital zircons, but also include Neoproterozoic and Permian and Triassic and Cretaceous individual ages, which, as I will show you in a couple of slides below, have not been found in the underlying sedimentary sequences and represent the early signal of a change in the configuration of source areas. On the other hand, due to the poor zircon yield of the overlying Paleocene Rumillaco formation, we were only able to date 5 zircons represented by Mesoproterozoic ages at around 1 and 500 million years and a couple of grains with Permian ages. In the diagram on the right, we conducted a multidimensional scaling analysis, which basically provides a relative measurement of the dissimilarity between the tridal zircon age distributions. This is the further apart the samples are separated, the stronger the differences between the tridal geochronological fingerprint. So in this case, we can see that the Rumillaco and the Neme formations are not that different in terms of the tridal geochronology, although we have to consider the very limited amount of grains we dated from the Rumillaco formation, for which a solid geochronological characterization is part of our ongoing work. From the Mandarina 1 well, we successfully analyzed 11 samples from the lower Cretaceous Caballos formation and the upper Cretaceous Paleocene Villeta and Neme formations. From the histograms and the kernel density estimates, we can see that the Caballos formation is mostly represented by ages around 1 and 1.5 billion years, whereas the Villeta and the Neme formations these formations record a relative reduction in the abundance of the tridal zircons with 1,000 million age years. 1,000 million age years. Million years age. Additionally, as I mentioned before, the Neme formation received the first input of Permian, Triassic, and younger sources. Finally, and as shown in the figure on the right, we can see that the Caballos formation is similar in terms of the tridal geochronology when compared with the Villeta formation, but strongly differs with the Neme formation, which is mostly associated with the appearance of Permian and younger detrital zircons. Now, in this slide, I show you a summary of the multi-method provenance analysis we conducted on Cretaceous strata described along the measured stratigraphic sections located near the Florencia area. So this figure shows the results obtained for samples from 3 sections for which we have the most data to date. And as you can see, we aim to integrate as much evidence as possible from a combination of petrographic, geochemical, and geochronological analysis, which have been mostly focused on the Cretaceous strata so far. We do not need to get into the details, but we can broadly see that the Caballos formation is represented by highly siliceous rocks as expected given the quartz-rich composition. Sandstones from the Villeta formation also have high contents of quartz and has a similar distribution of the tridal zircon ages in comparison with the underlying Caballos formation, but is characterized by a relative upward decrease in the abundance of 1 billion year ages. In red, we provide a mean apatite uranium lead age, which supports the provenance from crystalline rocks with Mesoproterozoic cooling and or crystallization ages. And regarding the whole rock geochemistry, it is possible to observe a slight decrease of the silica content in samples from the Villeta Formation compared with the Caballo Formation, accompanied by a relative increase in the barium concentration and a virtual decrease in the strontium abundance. In summary, the result of the provenance analysis we have gathered so far suggests that both the lower and upper Cretaceous Caballos and Villeta formations, respectively, are mainly characterized by the presence of compositionally evolved detrital components dominantly sourced from cratonic sources, forming, for instance, the basement of the Garzón Massif. This may account for the high quartz content and the dominance of Mesoproterozoic detrital zircon ages. The overlying Neme formation reflects a marked change in the source area configuration indicated by the appearance in higher abundance of Permian, Triassic, and younger material, which could have been derived from the uplifting Central Cordillera. This suggests the existence of a proper connection between hinterland domains and the Putumayo foreland basins during the late Cretaceous, which, however, was likely discontinuous, as we will see later in this talk. The relative contribution of compositionally juvenile material, which might be related to magmatic rocks forming the crystalline basement of the Central Cordillera, was dramatically increased during the accumulation of the Pepino Formation, as suggested by the higher proportion of Cretaceous and Paleocene Eocene detrital zircons. This supports the already proposed interpretation of accelerated exhumation uplift of the hinterland during the Paleocene Eocene, which was contemporaneous with the synergenic deposition in high energy fluvial systems of the Pepino conglomerates. And our results of the whole rock geochemical analysis of siliciclastic rocks are in good agreement with the observations from the detrital zircon geochronology and allowed showing the marked differences in terms of the lanthanum and thorium concentrations when we compare the Pepino conglomerates and the younger sandstones and moonstones from the Orito group with the underlying Cretaceous strata. The latter are composed of quartz-rich sediments derived from silicic sources with geochemical affinity to the upper continental crust, alike Mesoproterozoic cratonic units such as those exposed along the Garzón Massif and other domains located farther to the east. Whereas the Eocene and younger rocks are compositionally more diverse and seems to have provenance from more juvenile and mafic sources, such as arc-related Cretaceous and Paleocene units of the Colombian Central Cordillera. Well, so now in this part of the talk, I am going to show you a summary of the results of our inverse thermal modeling, which we conducted by integrating apatite fission track and zircon, uranium, thorium, helium data obtained from over 40 samples collected from the Garzón Massif, the Macarena Range, and the Guaviare Complex or the Baupés High in the northernmost margin of the Caguán Putumayo Basin. It is worth to mention that besides the thermochronological ages, additional input for the inverse thermal modeling was derived from field relationships between the studied geological units, which were found during our geological mapping work. Okay, so for the Garzón Massif, we have analyzed 34 samples of Mesoproterozoic metamorphic rocks, which are unconformably overlain by Cretaceous strata, as Alejandro showed you earlier. This stratigraphic relationship allowed us to infer that basement rocks were at or near the surface during the accumulation of Cretaceous rocks and were subsequently buried and reheated to temperatures above the apatite Partian annealing zone, which are between 60 and 120 degrees Celsius. Then, during the middle late Miocene, the Garzón Massif started to be rapidly exhumed, as suggested by the newly obtained and previously published apatite fission track ages of around 10 million years. Similarly, the Proterozoic rocks exposed along the Macarena Range was seemingly at or near surface temperatures during the accumulation of sedimentary rocks, which are probably Cretaceous or Paleocene in age. However, unlike the Garzón Massif, analyzed samples from the Macarena Range were reheated to temperatures within the apatite partial annealing zone and not above it, which is suggested by the presence of partially reset ages and short fission tracks. In this region, the onset of cooling exhumation apparently started earlier during the Oligocene and early Miocene. Although the new data, which we hope to have soon, will help us to better constrain the thermal history of the Macarena range. Finally, the Mesoproterozoic metamorphic and Neoproterozoic intrusive rocks exposed in the Guaviare region or the Baupeil High show more complex thermal histories, which suggests that these units could have been near at or near the surface during the accumulation of the San Jose Formation, for which tentative Cretaceous accumulation age has been interpreted, although it is still barely constrained. Nevertheless, additional evidence for the probable surface exposure of Neoproterozoic rocks of the Guaviare complex is the presence of 600 million year ages detrital zircons in the Neme Formation, suggesting that alkaline intrusives could have been part of the positive relief forming the sediment source areas during the late Cretaceous. Subsequently, analyzed samples were similarly buried and reheated to temperatures below or slightly within the apatite annealing zone, as indicated by the presence of partially to non-reset cooling ages. This could have been a consequence of the accumulation of a thin Cenozoic sedimentary cover in this region of the foreland system, as also suggested by the seismic data. Okay, so in this part of the talk, I leave my colleague Sebastian Jimenez to talk about the stable isotopes, boreal temperatures, and the thermal maturity of the Cretaceous strata.
Okay, can you see the screen?
Yes.
Okay. So here in this section, we're going to take a closer look of the Villeta Formation. But here we are going to focus on the isotopic and thermochronological perspective. As we might know, the Villeta Formation has been proposed as a potential source of hydrocarbons in this basin, right? However, to evaluate such potential, we need to get a much closer look at the maximum boreal temperatures. So here in this project, in order to address this subject, we expanded our geochemical toolkit and incorporated two independent proxies. The first of them corresponds to the oxygen stable isotopes in carbonates, which is basically a tool that helps us to reconstruct past temperatures. Here in the y-axis, we have the oxygen isotopic results obtaining carbonates from the Villeta Formation. It is important to mention that our samples were basically collected in the northern part of the basin. Sorry. Yeah, in the northern part of the basin. So we basically focus on a wide range of materials. So we included samples that, at least in the macroscopic scale, they seem to be fresh, but also we included some diagenetic products. Why? Because they basically show us the maximum temperatures at which these samples could be exposed. Okay, the results basically reflect two things. The first of them is the isotopic composition of the fluids that were in contact or were present at the time of formation of these carbonates. And the second factor is temperature. So when I mention or I say formation, I refer either to primary deposition or a secondary process, such as recrystallization or diagenetic alteration. Okay, as we can see from the results of the Villeta Formation, most of our samples lie in the range of secondary process. So it means that at some point, these carbonates experience thermal resetting. Okay, but just by combining our results and the isotopic composition of the potential fluids that were in contact with these samples, we reconstructed paleo temperatures that are in the range between 20 and 115 Celsius degrees. So it is possible that these low temperatures might reflect a primary signal. So these samples probably were not so affected by a thermal effect. However, the greater temperatures should indicate the maximum burial temperatures that these samples reached during the geologic time. Okay, so with this proxy, we have a first approximation, a first estimate of maximum burial temperatures for the Villeta Formation. Okay, here we just move to the next proxy that corresponds to fission tracks in apatites. In the left panel, we have a time temperature diagram that basically represents the thermal history of this rock that corresponds to the Villeta Formation. So here in green, we have the time of deposition of this unit that spans between 100 to around 85 to 89 million years. So we know for sure that at this time, this rock was on the surface, right? However, after deposition, this sample started to get buried and reheated. But the question is, how much reheated? Thanks to the fact that we also have an idea of the fission tracks length in this sample, we know that this rock spent a good amount of time in the partial annealing zone. That is basically a thermal range of temperatures between 60 and 120 Celsius degrees, where any fission track that has been formed could be easily removed or at least got shorter because of thermal heating. So our results show that most of the tracks that correspond to this sample are or have a track length below 40 micrometers. So we know from previous studies that the fission tracks originally formed at 16 micrometers. So once the sample gets into the range of the partial annealing zone, the tracks become progressively shorter. So based on this evidence, we can conclude that this sample was buried or reheated to temperatures within the range that we already mentioned, 60 to 100 Celsius degrees. And it is supported by the presence not only of partially reset cooling edges, but also for the fact that we have short fission tracks. Okay, so once we combined our two proxies, we can basically recreate the thermal history of the samples that were evaluated here. It means the rocks from the Villeta Formation. And as we just explained before, we know that these rocks never reached temperatures above 120 Celsius degrees. So we can establish our maximum burial temperature at this boundary. And the second information that we can get from the test that we just conducted is that the temperatures calculated or reconstructed from the Villeta Formation are within the range of the values that have been proposed for oil generation. That is depicted here by this diagram. Okay, finally, we also conducted some organic geochemical analysis, and again, also in the rocks from the northern part of the basin, so those regions adjacent to Florencia. And the results indicate that most of our samples are in this range, so between measure and immeasure thermal maturity. However, we have also a subgroup of samples that seem to reach a greater thermal maturity, and probably they were in the early stages of oil generation. So based on this information and the fact that we have also some stratigraphic sections going southward, it means in the Mocoa and Sibundoy regions, we might expect that the rocks from the Villeta Formation, or at least the Coniacian to, the Cenomanian to Turonian deposits, in the regions of Mocoa and Sibundoy probably reached greater temperatures, they probably reached higher thermal maturity, and probably if we conducted the same analysis, they will be in this range. So it looks like the potential of the Villeta Formation as a source of hydrocarbons seems to be very positive. So I think that's all. Thank you, and Alejandro will continue with the presentation.
Thank you, Sebastian. I don't know if you are looking my screen again. Let me please put, okay. We are again online. Okay, it's visible, yeah, I imagine.
Yes.
So for concluding, after integrating all this information, we are showing some schematic or paleogeographical maps we've been working on. For instance, we will start with the Lower Cretaceous. We can see here, for example, an spectra of zircon in the right part of this slide, and all the zircon recovered from the Caballos Formation are mostly Proterozoic. There is no, as Santiago showed, there is no Phanerozoic signature in it. So this means that probably in this part of the area, when these deposits were collected or so, the sources were likely the Guyana Shield and the Garzon complex, and they were exhumed. Someone was asking about why there is no Cretaceous at the eastern side of the Florencia Paleohigh. Well, yeah, this is because it was confined in the sedimentation. The thing is, we don't know clearly in this Caqueta basin, the center here, which kind of sediments are lying there. If this is the pre-Cretaceous, if there might be Cretaceous here as well. We have no idea because there is no survey here that can give us that information. Everything is buried, so it might be, but we just don't know. This is for the Lower Cretaceous. We have a schematic showing we have now know that the unconformity existed. So the Florencia High was positive relief in the Lower Cretaceous. Then in the Upper Cretaceous, we already got more marine incursion. We have the connection between the Magdalena Valley Basin and the Putumayo Basin. There were all the ammonites that I showed you were swimming here. They were living here in this area. And they were confined by this eastern boundary, which is also the Garzon complex and Florencia Paleohigh. Because we don't know anything about any Turonian or Cenomanian deposits, it's eastward of the Florencia High. We know that in Macarena, there are some Cretaceous, Upper Cretaceous deposits. So we have some extent of marine incursion here, and the Macarena was again buried by these deposits. Okay, so then for the Paleocene, we got some exhumation of the Macarena Range. We got, this means, for example, that the Macarena height probably was uplifting, and sedimentation in the Paleocene was still confined when we got the Neme and Rumillaco formations. The Rumillaco probably sourced mostly by the Central Cordillera volcanic arc, and the more quartz component of the Neme formation most likely related to erosion of this cratonic basement here. That's why the Neme formation is very localized. I think Giovanni was asking what was the difference. Chronostratigraphically speaking, these units are mostly equivalent, but compositionally they are very different. But yeah, the Neme formation by definition is flow Neme because it implies that the rock is impregnated with oil. So it's very problematic still, but we are trying to figure out what is the current age of the Neme, if we still find some mudstones intervals or so. Finally, for Oligocene Miocene, we got major exhumation of the Andes. We got the uplifting of the Garzon Massif. And from now on, the Magdalena Valley Basin and the Putumayo Basin are now separated. They are not connected anymore. The marine connection was interrupted, so the sediment routing system were interrupted, and therefore the migration for oil afterwards produced in these basins was also interrupted now from this moment on. Then by the Pliocene, we got the final exhumation pulse and the current situation from the northern Andes as it is. Yes, and then with this, it's concluded part of the paleogeographical just schematic. We are still working on this development of these schematics, integrating our new data every day, and still waiting for some information on the exhumation of the Araraquara High and the Guaviare High for integrating to these complex models. So now Santiago will explain some part of the thermokinematic modeling we perform in one of the sections, just for concluding.
Okay, so far during our research project, we have constructed 7 structural cross-sections from the integration of surface and subsurface geological and stratigraphic observations. In the following slides, I will rapidly show you one of them, which is located across the Pantera 1 well in the Upper Magdalena Valley and the Cachalote 1 well in the Putumayo Basin. So the geological observations, together with the model thermal evolutions from our own data and additional thermochemical constraints, reconstructed the kinematic evolution of the cross-section from the Upper Cretaceous to the Eocene and Oligocene boundary, which I will show you in 3 time stages. The first stage is represented by the end of the deposition of the Caballos and Villeta formations, for which, according to the spatial variations in thickness on both flanks of the Garzon Massif, we interpret a rift-related tectonic setting and associated gravants, mostly developed during the Jurassic and the earliest Cretaceous. Therefore, it seems that during this time period, the basin configuration was represented by different depozones, spatially distributed from the Upper Magdalena Valley to the present-day Piedmont region. The following stage shows the initial basin inversion and the early generation of a Paleo 4 deep. Evidence for this interpretation is the observed unconformity below the Neme formation and the presence of growth strata within the Rumillaco formation, which thickens from northwest to the southeast and then become progressively thinner. The final stage, reconstructed for the Eocene Oligocene, shows the generation of a deep piggyback basin and the deepening of the Paleo 4 deep, which is supported by the fully reset apatite fissile tract edges obtained from Proterozoic rocks forming the basement, which I showed you earlier in the presentation. And these edges requires the Garzon Massif to be buried and reheated to temperatures above the apatite partial annealing zone exceeding 120 degrees Celsius during this time period. It is worth to mention that most of the sedimentary pile accumulated on top of the Garzon Massif was likely represented by the syntectonic deposits of the Pepino Formation, which, as suggested from our provenance analysis, were mostly sourced from rocks of the Central Cordillera. Regarding the evolution of the hydrocarbon system, it is worth to mention that according to our new thermal data and the derived structural reconstructions, the presence of a deep piggyback basin and a well-developed 4 deep during the Eocene could have been associated with the generation of paleokitchens for the organic-rich Cretaceous strata. And finally, the advance of the orogenic evolution of the easternmost Andes and the associated occurrence of deformational episodes along the Piedmont region and the Foreland Basin as well could have resulted in the progressive erosion of the above-mentioned paleokitchens. Nevertheless, it could be expected that the produced hydrocarbons during the Eocene Oligocene migrated somewhere could have been preserved either by stratigraphic and or structural traps. Okay, so that's it. Again, Alejandro will summarize and conclude the
I think I'm again online. Okay, yeah, just for summarizing,
yes.
Finally, we make a list of these kind of conclusions. So this basically resumes all we were talking about the different periods of exhumation of the Garzon Massif that are documented by stratigraphic information. It's very important to know that at first glance, the thermochronological information indicated only Miocene exhumation. But as we know now, by combining our provenance analysis and thermochronological data, and of course the surface geology and subsurface unconformities that we observed, this was not true. The massif was exhumed several times and was taken to a depth. It was annealing of the fission tracts. So they have 2 outcomes. The first one is that all the ages are annealed, and the second one is that the basin reach temperatures that are good for maturation of organic matter. So this is the main outcome of this research. Of course, we know the Upper Magdalena Valley and Putumayo basins are, in fact, during the late Cretaceous, were the same basin, where they connected. There are no different source rock or stratigraphic systems over there. It's the same Cenomanian to Coniacian deposits, which are very important for the regional correlation. So the source rock was distributed among these areas evenly. The only thing is that when it was exhumed, all the cover was removed and the depositors were isolated, but in the origin of these sediments, they were the same, okay? And we see, for example, several stratigraphic traps and possibly structural traps that are combined and are controlled, of course, because of these paleo heights. We talk about a lot of the Florencia height, but there are other heights that are easterly, for example, the Macarena and the Baupés height. And we think these heights probably are controlling also similar traps, probably from a Cretaceous oil system, or maybe exists the possibility. We are considering this, of course, if there is a Paleozoic oil system that is working there. But we don't know yet because there is no survey in these areas. Still, we got the basement heights, and they are, of course, confined in the sediments. So, yeah, as Sebastian told us, the organic matter content, the Tmax, and the isotopic information, along with the thermochronological data, indicates that there were paleo kitchens in the area. So we don't need to think about the kitchens elsewhere, but in the Putumayo Basin and very near our accumulation areas, we have the kitchens. That doesn't mean that other kitchens far away, for example, in the South Putumayo or in the Upper Magdalena Valley, were not also participating in sourcing oil to the reservoirs. So this is good potential for the basin anyway. Well, this is an approach that should be also have a very important structural component for understanding this place, but also we have to quantify in time the evolution and the exhumation processes that took from the basement heights. So in this way, we can know the timing of the play formations and the oil migration, and if this was adequate for accumulations to happen. And also an important, and this is the last one, in Ecuador, the ITT fields are very rich fields in oil, and they are in the same structural domain as the Capella field. So they are in the western part of the Macarena High, or the Iquitos High, as they call it in the Ecuador. This means they share a same structural domain. So are these related, these oil systems? And how we can try to study them? Is this a corridor for oil migration, or was it? Yeah, finally, these are the possible traps or perspectives that we can have in the basin, locally related to traps and the stratigraphic traps and structural. And this integrated atlas we are working on, we are producing all this information in an atlas that will be available for mobile devices and also physical, where all this chronometric information, lithological, well, and seismic information will be combined for making easy access to the consumer or to the interested researchers to acknowledge how these sequences present different signatures in terms of geochemistry and age. Finally, I want to thank to all these people from the Geological Survey, the ANH, of course, the staff of the Dirección de Asuntos Nucleares and the survey. And finally, Professor Mauricio Bermúdez in the UPTC. We worked with him with the thermochronology, some thermochronological analysis of uranium thorium field. And finally, last but not least, all the communities and local authorities from these departments. In this area, we got the opportunity to explore many interesting places. We're looking forward to continue to do it so. Thank you very much. I don't know if still so many questions or whatsoever. Thanks.
Okay, thank you, Alejandro. From the ANH, we would like to thank the three speakers of today, Alejandro, Sebastian, and Santiago. It's been a really great talk for us, and as well, more than the talk, is a really great work about the history and the evolution of the Caguán Putumayo. It seems that all of the questions have been already answered by Alejandro into the chat room, and we would like to remind all of the people that is in here that the ANH got financial support for thesis for last year students of the undergrad and postgraduate students for MinCiencias is opening a registration process for financial support during the first week of June. It's an agreement between the ANH and MinCiencias. For MinCiencias, contact Diana Rua. And from the ANH, you can contact us, Arles Gutierrez or Daniel Rodriguez, and data with no cost for research in frontier basins. So this is an agreement between the Geological Service and the ANH. And if you want the contact from the Geological Service, you can contact Pedro Rangel. So we would like to thank all of the attendees, and again to thank to all of the speakers of today. So see you next week for the Caribbean Bay Fairways presentation. Thank you again.